Okay, so this will be the implementation of the Fibonacci search, by the way. So in this one right now, I'll begin to illustrate to you the step by step of this one. And in the step one, you have to definitely generate the Fibonacci number actually. So in this case, this will be our numbers of array. So we have let me just give, I mean, put the indexes here so that we could be able to easily know. So there are 13 elements in our array. So in generating that one, so it must be absolutely sorted right now. We have 1, 5, 10, 8, and 5 for 29, 30, 39, 39 for the 8, 57, 60, 70, 38. So considering that that is actually sorted manner as well. So right now, what will happen, what we'll begin to do in this one, we will be going to definitely do this step by step manner. And first thing that you need to consider is generating the, I'm so sorry, let me change the pen color. This is actually generating the Fibonacci number. And for generating the number of Fibonacci, that must be greater or equals to the n. So when you say greater or equals to the n, what will be your implementations, right? Implementations here, it must be that you will be going to have a specific like Fibonacci number of within this array bound right now. So you have 13 specific element that you have in your array. So what we'll be going to do if you the Fibonacci sequence that will be going to start with 0, right? So in your 0, then the next will be 1. Then 1 times I mean 0, 1, 0 plus 1, it will become 1. 1 plus 1, it will become 2. 1 plus 2 will become 3. 2 plus 3 will become 5. 5 plus 3 will become 8. Does that 8 does not greater than or equals to n yet? No. 8 plus 5 is equals to 13. So 13 is already equals to the 13, so we'll just stop right there. This will be your Fibonacci sequence already right now. So considering that, for example, you have to deal with this one. The Fibonacci 0 is 0. The Fibonacci 1 is 1. Fibonacci 2 is 1. Fibonacci 3 is 2. Fibonacci 4 is 3. Fibonacci 5 is 5. Fibonacci 6 is 8. Fibonacci 7 is 13. So since your first initialization, your Fibonacci M right here will be the last Fibonacci. That will be the what will as what we have mentioned that in your initialization, that is the smallest Fibonacci number, which is greater than or equals to the size of the array. So since this will be 13, so that is the F Fibonacci 7. So that is definitely 13. The value is 13. Okay. And your Fibonacci 1 minus 1, that is the Fibonacci 6. So that is technically 8. And your Fibonacci 2, that is Fibonacci 5. That is 5 right now. Okay. So that is exactly what you will be going to do in the initialization step, in step 1. So given that your offset is set to negativeness, what we have mentioned earlier in the previous video. Now, in this algorithm, since you're able to have the step 1 already, this will be the times you will be going to calculate already the, no, it will be, we'll just be going to put that already in your step 1, the calculation itself, so that we could be able to update that in the next iteration already then. So here then, we will begin to find the index element in your in this one. So suppose that this will be the iteration. So you will not begin to specify each steps already. I want you to deal here a step by step index, for example. to begin to find that one. Exactly. So your iteration one is the calculation for the index. That must be the index is equals to the minimum of your, which will be the offset plus the Fibonacci 2, what will be the Fibonacci 2, and that will be compare to the n minus 1. So what will be your n minus 1? That is 13, 12, diba? So later on, we'll be going to see that anyway. So any we'll compare that into the target actually. So this is unnecessary this one here. Since, this will be your implementation for finding the target. So anyway, um I want you to use this formula. Let me just correct everything so that you will begin to have the same number. So, wala na siya. So your calculation right now, that is the offset. What is your offset? Negative 1 plus the Fibonacci 2. What is the Fibonacci 2? There is 5. Negative 1 plus 5, that is absolutely, I'm so sorry, that really goes off right now. Let me find the calculation. Okay, here it is. Negative 1 plus 5. So negative 1 plus 5, that will become 4. So since that is 4 right now, you will exactly compare 4. What is index 4? Index 4 is 24. What is our target? I was not able to prove to display here. I'm so sorry. So suppose that you'll begin to search 65. Okay. So does it equals to 65? No. So therefore, you will continue with the iteration number 2. So for this one, before going to, if you're going to calculate that one, let me just go ahead and step by step the process with 1, 2. Okay. So in this case right now, we'll be going to definitely calculate that here in your iteration number 2. By the way, you have to update first in your iteration number 1 the calculation of the specific Fibonacci. You will not go to the iteration 2 if you were not able to have the calculation yet. So in this case right now, what will happen in your Fibonacci M, Fibonacci 1, and Fibonacci 2? That is minus 1, minus 2. However, moving into was like that. Now, in your Fibonacci M earlier, since this is absolutely your array, diba? As what we have stated that if your target, if that is greater than to your current element. So we'll begin to illustrate that here and then how does it work with the implementation, okay? Just 1 second. Okay, as what we have mentioned, before you will begin to update first. So you have to also put here that if your target is less than, or if your target is greater than, you have to specify here then. So this will be, for example, your target is 65, right? So since you were able to compare 24, if it is equals to 65 now, so therefore your target is greater than. So 24 is, no. That must be 65 first. 65, because that is your target. So 65 is technically greater than 24. So what will happen? You have to specify here, move to right subarray. Subarray. So since moving to the right subarray, you have to update your offset to +1, as what we have mentioned. So if the element, actually, I have to shift the search to the right side by moving the offset forward and adjusting the Fibonacci number as well. So moving forward, what will happen in your offset? Since right now you're technically at 4, so it will become 4 plus 1. If your target, if it is less than, say for example, say ang imo na ano subong is 75, for example. So, 75 is 65 is less than 65. So what will happen? You have to technically do the other thing. Shift the search to the left side. Definitely, if and only if an imo na find here is definitely 75. So you have to shift to the left side because we can definitely identify that your element that you're searching is at the left side, and then your offset will become as is, diba? If you were able to identify that one. So here then, your Fibonacci M for this one, since that is your target here is greater than. So you will be going to find this here. So Fibonacci M, that must be equals to the Fibonacci 1. What is the Fibonacci 1 earlier? That is 8, diba? So you will be going to put here 8. And your Fibonacci 1 is Fibonacci 2. What is Fibonacci 2 here? That is 5. So technically, Fibonacci 2 will become Fibonacci M, 8 minus 5. That is equals to 8 minus 5, that is 3. Diba? So what will happen right now? Since your offset is 4, then it must be, since moving the offset. By moving the offset, so let me just, okay, 1 second. Okay. By the way, class, let me correct for the offset. It will not be going to n plus 1. It will become 4. Because as what we stated in the rules earlier, if the target is greater than, move the range to the right subarray, then update the offset with that specific number of the current search option, latest search. So that is 4, so your offset right now will become 4. So we'll still remain that there. If your target, if it is less than, you will retain the current offset and you will not change anything. Okay. Now we will be going to proceed with the iteration 2. For iteration 2, you will be going to calculate index is equals to the offset plus Fibonacci 2. So what is your offset? That is 4 plus Fibonacci 2, that is 3. So technically it will become 7. So comparing the 7 element, what is the 7 element? That is 39. So does 39 is it equals to the 65? Technically not. No. So what will happen? Update your Fibonacci M later on. So 65 is still greater than to the 39. So what will happen? You have to move to the right subarray. To right subarray. Okay, this is how it works. Now then, update. Put an update here. Put update here. And then your Fibonacci M, what will happen? Your Fibonacci M, Fibonacci 1, Fibonacci 2. So if the target is greater than, this will be the rule, that is equals to the Fibonacci 1. What is the previous Fibonacci 1? That is 5. What is the previous Fibonacci? 1 is equals to Fibonacci 2. What is the previous Fibonacci 2? That is 3. So technically, that is Fibonacci 2, Fibonacci M minus Fibonacci 1. So 5 minus 3, it will become 2, right? So definitely right now, 2 is your current Fibonacci 2. Then your offset will be updated into this one, 7 already, right? Because you will be going to copy that one since the target is absolutely in the is actually greater than the value of your current search. Now you will proceed with the iteration number 3. For iteration number 3, calculating the index is equal to the minimum offset, then plus the Fibonacci 2. What is the offset? That is 7 plus the minimum, I mean the, what do you call this one? Fibonacci 2 is 2. That is 9. So what is array 9? Index 9. Technically, that is 57. So since 57, is it equals to 65? No, still. So therefore, 65 is still greater than to the value of 57. So we'll move to the right subarray still. Right subarray. And calculating another update of your Fibonacci M. Your Fibonacci M right now, that is Fibonacci 1. That is your Fibonacci 1 earlier, that is 3. And your Fibonacci 1 is your Fibonacci 2, right? Yeah, what is Fibonacci 2 earlier? That is 2. And Fibonacci M is definitely calculating the Fibonacci M minus Fibonacci 1. Your current Fibonacci M is 3, and your Fibonacci 1 is 2. So 3 minus 2 is equals to 1. So therefore, your offset will be updated into this 9, and you will proceed with the iteration number 4. So what will be your iteration number 4? You're in your index right now will become minimum offset plus Fibonacci 2, the same. The same implementations that you will be going to use. Your offset right now that is 9 plus Fibonacci 2 that is 1, that will become 10. So by assessing that one, what is the 10 value? 10 is 65. 65. Does 65 is equals to 65? Yes, definitely. So therefore, you will not be going to proceed anything because you were able to find the element. So you just have to return 65 is found at specific. You were able to found at index 10. So that is the procedure. What if class? Anong matabo if instead of 65, yung search natin si say for example, mas lower 48. So searching 48 right now, step 1. Okay. Let me check if may 8 na kanina. So that we could be able to figure out what happened. Okay, 974 and 10. Okay, so this will be exciting. For step 1, the same implementation. So as is now, for step 1, this will be your basis. So I will not be going to ano lang, update here. So that is retain now here. This is just an example. I assume that this will be still the same here. And I will be going to proceed with the iteration 1 already. So for iteration 1, the same thing, because of course your iteration 1 is 48 with 48 is this key value. Now in your iteration 1, you do have the negative one. Your minimum right now is 13, the same. That is your Fibonacci 2 is 8, that is correct, and your Fibonacci 5 is Fibonacci 2 is 5, gap 1, that is 5, so offset is negative 1. So here then minus offset is negative 1 and Fibonacci 2 is 5, so it will become 4 and 4, the same thing. So 24. 24 is not equals to what will happen here. I will not be going to calculate everything out. So equals negative 1 plus 5 equals to 4. Then 4, does it equals to your array 48? No. So therefore, what will happen? Fibonacci M, Fibonacci 1, Fibonacci 2, offset will become 4. Then Fibonacci M is 8, diba? Earlier, that is since your 48 is greater than 24. So search or move to right suffering. In this implementation, as we go along, so Fibonacci 1 is equal to Fibonacci 2. Your Fibonacci 2 earlier, that is 3. Ano nyo? Am I right? So Fibonacci 1, or Fibonacci M, that is Fibonacci 1. Okay, your Fibonacci 1 earlier is 5. Diba? Your Fibonacci M is equals to Fibonacci M is equals to Fibonacci 1. So your Fibonacci 1 is 8. Your Fibonacci 1 is equals to Fibonacci 2, that is 5. Okay, correct. Fibonacci 2 is 5. Fibonacci M is equals to 1. 8. So the same thing. 8, 5. So your calculation Fibonacci M minus Fibonacci 1, your M right now is 8 minus Fibonacci 1 is 5, that is 3. So you will proceed with the iteration number 2. Your iteration number 2, your offset, that is 4, then plus the Fibonacci 2, that is 7. So 7. So 7 is it. What is the element of 7? That is 48. 48. So 48, does it equals to I don't know. Are we able to? No. Diba? Am I right? Fibonacci. No, 7. By 8. My God. 7 is 39. Buta ka, sir. 39. Diba? And 39. Is it equals to 48? No. So 48 is still greater than 39. And we will be going to move to right suffering. And then what will happen here? Your Fibonacci M is Fibonacci 1. Your Fibonacci 1 here is 5. And your Fibonacci 1 is your 2. The Fibonacci 2 here is 3. Your Fibonacci M is, 2. Fibonacci M minus 1, 5 minus 3 is equals to 2. So therefore, your current offset will be updated into 7. Okay. Now, iteration 3. Iteration 3, your offset is 7 plus Fibonacci 2 is 2, is equals to 9. 9. What is 9? 9 is, that is here, 57. 57 is it equals to, we got to connect 48. So, no. So 48 is less than. So this is what I'm looking. So 48 is less than the value of 57. So therefore, move to the left suffering. Because I was not able to illustrate that. left to right. So what will happen here? Fibonacci M, Fibonacci 1, Fibonacci 2. You will be going to base in the other rule. Since less than, this will be the implementation. Fibonacci M will become the Fibonacci 2. Fibonacci 2 earlier is 2. And Fibonacci 1 will be the calculation of Fibonacci 1 minus Fibonacci 2 in the previous one. So Fibonacci 1, that is 3, and Fibonacci 2 is 2. 3 minus 2 is equals to 1. So, therefore, your Fibonacci 2 will be Fibonacci minus Fibonacci 1 in this current. So, 2 minus 1, that is definitely 1. So, right now, your offset, you will not be going to update any offset. You cannot use 9 because that is less than 57 is actually greater than the target. So your target is less than the value of 57. So your offset will retain 7 earlier. So that's how you will deal. In your iteration 4, what will happen in your iteration 4? Oh my god, it went off again. So let me just go ahead and find that once again. Where is it? So what will happen here? You will proceed with the iteration 4. Your iteration 4, your offset is 7, plus your iteration, your Fibonacci 2, that is 1. So definitely 8. What is 8? Your 8 right now, what is the element of 8? 8 is 48. So, right now, 48, is it equals to 48? Yes, exactly. So, that's why you will return 48 is found at index 8. So this is how you will run through the process of the implementation. I was just able to illustrate to you the step-by-step process of that one in terms of the less than and greater than, because I don't want you to have or any to experience any frustrations with that one. So technically that's how we will work with that one. Thank you so much. Now we're going to also explain another sorting technique, any searching technique in the other videos. Thank you. Bye bye.